Welcome back, guys. In this question, we have the function f of x equals negative 40x squared minus 90x plus 25, and we have to find the zeros with two different methods. So when they're asking for the zeros of a quadratic, they're pretty much asking for the x-intercepts. So if we write this function out here, we got y equals negative 40x squared minus 90x plus 25. So how can we find the x-intercepts of this? Well, the x-intercepts always have a y value of 0. So notice this now is just a quadratic equation, and there's multiple ways to solve this. We can factor it. We can throw it in the quadratic formula. The first method, let's try the quadratic formula. We know quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So in this case, what is the a value? The a value is negative 40. The b value is negative 90. The c value is 25. So this is negative b. So this is this sign here will change. So this would be 90. This would be plus or minus b squared, so it's negative 90 squared minus 4 times a, which is negative 40, times c, which is 25. And this is going to be all over 2 times the a value of negative 40. So from here, we'll have 90 plus or minus negative 90 squared, that is 8,100, positive. And then negative 4 times negative 40 times 25, if you multiply all those, you get positive 4,000 from those. And this is going to be all over negative 80. So 8,100 plus 4,000, that gives us 12,100. And then the square root of 12,100 is 110. It's going to be all over negative 80. Right? So from here, we can find the two cases. So basically, the two x-intercepts is either going to be 90 plus 110 divided by negative 80, or 90 minus 110 divided by negative 80. So this here, 90 plus 110 is 200, divided by negative 80, that is negative 2.5. And then here, 90 minus 110 is negative 20. Negative 20 divided by negative 80 is positive 0.25. So the two x-intercepts here are, the two answers we got are x equals negative 2.5 and x equals 0.25. Right, so the first method was with the quadratic formula. This is how you do it. Right, so that's one method. What's another way we can find these x-intercepts or solve this quadratic equation here? Well, we could factor it. So factoring, you always want to see if you could take something out first. And notice in this case, from negative 40, negative 90, positive 25, best to take out a negative 5 to start. So we'd be left with 8x squared. 90 divided by negative 5, that is what? 18. So positive 18. And then this here, 25 divided by negative 5 is minus 5. Right? So we pretty much have to factor 8x squared plus 18 minus 5. So if we do that on the side, 8x squared plus, oh sorry, this should be 18x. My bad, I forgot the x there. So 18x minus 5. So two numbers that multiply 8 times negative 5 is negative 40 and add up to positive 18. So this would be 20 and negative 2, 20 and negative 2. So decompose this. So 8x squared plus 20x minus 2x minus 5, right? So we're just taking that middle value, decomposing it to those two numbers, 20x minus 2x. From these two, we could take out a 4x, so we'd be left with 2x plus 5. And from these two, we could take out a minus 1. So this would be 2x plus 5 as well. Then we could take out a 2x plus 5. So this would be 4x minus 1, like that. Okay, so from here, we took this, factored it to 2x plus 5, 4x minus 1. So the solutions are 2x plus 5 equals 0, or 4x minus 1 equals 0. So this here is going to be x equals negative 5 over 2. And here x would be 1 over 4. And notice that these two solutions are the same as those two. X equals negative 5 over 2 is the same as negative 2.5. X equals 1 over 4 is the same as 0.25. So two different ways, quadratic formula factoring to get the zeros or the x-intercepts for a quadratic.